Hey there, welcome back to this last video of the unit circle, and in this video we're going to go ahead and apply the unit circle to some trigonometry problems that you would normally see. All right, so I'm going to pick back up where we left off, which is with the unit circle. So here is our beautiful construction, and if you missed kind of like how did we make this thing, you can go back and view the last two videos. Heavy in concept, right? A lot of ideas, but here is the unit circle. Now, if your unit circle in your notes looks kind of ugly, what I've done, at least if you're in my class, is I've given you a printout of the unit circle in the back of your notes packet, so you can flip back there. It's the last page on the front side that will be your unit circle. But we're going to go ahead and use the unit circle. So, like, what's the point of having the unit circle? Well, we're going to be asked questions that say find these values. And what we're going to do is we're going to use our unit circle. Now, again, the main thing that you must remember is that your x-coordinate is cosine theta. Your y-coordinate is sine of theta. Okay, so when we're asked what is sine of 4 pi over 3, what I really want to know is what's the y value at at 4 pi over 3. So I go to my unit circle and I locate, okay, where's 4 pi over 3? Well, I know it's, right, 4 pi over 3 right there. Just past 1 pi, right? 3 pi over 3 would be just past pi. Okay, and we want the y value, we want the sine value, and that happens to be negative root 3 over 2. Okay, so I can go back to my problem and I say, hey, I know that this is negative root 3 over 2. And there's your answer. It's that easy, right? It's the y value. Sine is y. Okay, cosine of pi over 6. Well, that's the x value at pi over 6. So I go to pi over 6. That's in my first quadrant, right? And I say, okay, what's the x value? Root 3 over 2. Okay, so I go back up here and I say positive root 3 over 2. And that's it. Okay, what is sine of 3 pi over 4? Okay, and some tricks that you can notice too is look at the denominator. The denominator here is a 4, so I know that this is a 45-degree angle. Okay, so I can go back to my unit circle. 3 pi over 4 is right here. Okay, and they want, I believe it was sine of 3 pi fourths. That's my y value. Okay, and my y value is positive, root 2 over 2. So I put root 2 over 2. Okay, next, cosine of 7 pi over 4. So I go back to my unit circle. I find cosine of, okay, so here's 7 pi over 4. Cosine, that's my x value. Again, positive root 2 over 2. Okay, so root 2 over 2. Now, you'll also get quadrantals as well, and the last two examples kind of are quadrantals. They want what's cosine of 0, okay? So angle 0, pretty easy to find, and cosine, that's my x value, so the answer is 1. All right, how about sine of pi? Well, that's my y value, right, at pi. Okay, we all know where pi is here, and it's the y value. So that answer is 0. Okay, so that's how we use the unit circle. They're going to ask you what's sine and cosine of certain angles, and you just have to go ahead and find it on your unit circle, or eventually memorize it, and you're like, there's no way I can memorize it. Trust me, there's a way. There's a trick. I'm going to teach you the trick, okay? We'll talk about that later. All right, so here is some practice problems. I want you to please pause the video. I want you to give these a go. And again, remember, okay, cosine of theta, that's my x value, right? Sine of theta, that's your y value. So look at those angles. You can use your unit circle and find those values. All right. Okay, so hopefully you paused the video and you tried these. Here are the solutions. Did you get them? Did you get them? And remember, the sine values, you got to remember your sine values, right? X's are positive in quadrants 1 and 4, so negative in 2 and 3. Okay, your y value is positive in your upper quadrants, 1 and 2, and then negative down below, right, in quadrants 3 and 4. Okay, so hopefully you got these. What are some other applications? Well, they'll kind of get crazy on us, and they'll say something like this. They'll say, if sine of theta is equal to 1/2 find all the values of theta from 0 to 360. So the first note that you need to be aware of is look at this domain here. And the domain that they give you is 0 inclusive. So I include angle 0 and I don't include 360. But more so, note that it's in degrees. So they're going to want their answers in degrees, right? So theta is equal to, okay, I want to know where is my y value? Where is the y value? 1/2. So I go to my unit circle, okay, and I say, okay, where's my y value? 1/2. Well, first of all, it's positive, right? So y value, it's only going to be in quadrants 1 and 2. Okay, so hey, look, right here, here's 1. There's another one. Okay, so that is 30 degrees and 150 degrees. Okay, so theta is equal to 30 degrees and 150 degrees. All right, next example. If cosine of theta is equal to negative √2/2, find all values of theta from 0 to 360. Again, note that they're talking degrees. Okay, and √2/2, I hope when you see that you get excited, right? Because we all know that √2/2 is going to be a 45-degree angle. Okay, and I just want to double check, cosine is negative. So we want, where's the x value equal to negative √2/2 in our unit circle? Okay, and that's going to occur here and here, right? So look at our x value, negative √2/2. Okay, but I made the mistake, guys. Why didn't you tell me? So it's in degrees, right? So I want 135 degrees and 225. So theta is 135 degrees and 225 degrees. Simple. Okay, if cosine of theta is -1, find all values of theta from 0 to 2 pi. Okay, so now they're giving us radians. So I want my angles to be in radians. And where is cosine of theta? -1. Okay, so where's my x value? -1. And I hope you picked up on the 1s and the 0s. They only happen at your quadrantals. Can you say quadrantals? Quadrantals. Yes, right? So I go, where's my x value? -1. Hey, that's right here. Okay, and what is that angle in radians? Well, it is pi. Speaking of pi day is coming up. Okay, pi, right? Or it passed, depending on when you watch this. Okay, next, if sine of theta is equal to negative √3/2, find all values of theta from, and again, this symbol right here, I don't know if I talked about this. This is theta. Theta, you gotta get a good lisp going. Theta. It's from 0 to 2 pi. Okay, so where's my y value? Negative √3/2. All right, so theta is equal to, go to my unit circle, negative √3/2. So I know it's going to be in quadrants 3 and 4, right? Because it's negative. Okay, so I want my y value to be negative √3/2. Okay, here's one. Whoop, I found it. Here's the other one. Whoop, I found it. Okay, and I want, this is a pi third angle, right? A 60-degree angle. So I want it in radians, so 4 pi over 3, 5 pi over 3. So 4 pi thirds, 5 pi thirds. And there you have it. You'll notice that my unit circles, I've been circling and marking and everything, so it's pretty messed up. Again, if yours looks like this, if it's all messy, you can go to the back of your notes and you'll have one. Okay? All right, so here's some examples. Again, you know the drill. Please pause. Try it on your own. If you have questions, write them down. Make sure to ask them. Bring them to class. Okay? But pause. Here's the answers. All right, here you go. Okay. Something to pay attention to. Did you make note of the domain? Right? Did you use degrees when you're supposed to use degrees? Did you use radians when you're supposed to use radians? That's very, very important, okay? Did you get both angles if there's 2, right? So example 2 didn't have 2 angles, but the rest did. Okay, hey, that's it. That is it. That's how we use the unit circle. You pretty much just read it, right? X values are what? Sine or cosine? Cosine, very good. Y values are what? Sine, very good. What about tangent? That's such a good question. We'll talk about that next. Catch you next time. Peace.